In this video, we'll talk about how the project uses update attribute actions, variable nodes, and a conditional trigger to collect reaction time, key press, and accuracy data for each trial. The critical components responsible for collecting this behavioral data are in the recording sequence. First, you'll notice that the recording sequence has three variable nodes in it: RT, accuracy, and key pressed. Variable nodes always have to be given an initial value or the project will crash. Setting the initial value sets the type of that variable. The RT and accuracy variables have an initial value of -1. This makes them become integer variables. The key pressed variable has an initial value of a single period. This makes it become a string variable. I chose these values to represent missing values. If the trial times out without the participant pressing a key, then seeing these values in the data file would provide an easy way to know that the trial timed out. Besides, the values don't really make sense. For example, how could you have a reaction time of -1? The first node of the recording sequence is an update attribute action called reset variables. It resets the values of the variable nodes to their original default values. To see and edit how any update attribute action works, you can click on its attribute value list property. This will bring up an interface with 2 columns and at least 1 row. For any given row, the left column, or attribute column, should contain a reference to what we are trying to set, and the right column, or value column, should contain the value to which we are setting the thing that is being referenced in the left column. The value in the right column can be set directly or via another reference. In this case, we are making reference to the value property of each of the variable nodes on the left side and setting them to their original default values on the right side. To change a reference or the value that is being used, you can click on the box to reveal the button with 3 dots. Clicking the button with 3 dots will bring up the attribute editor and will allow us to make reference to the properties of other nodes of the project. For example, to make it so that we set the key pressed value back to its initial value of a single period, on the left side we make a reference to the value property of the key pressed node by double clicking on the value property of that node. On the right side, we simply enter a period. After the keyboard response trigger, there's a conditional trigger called check accuracy. Conditional triggers are like if-then statements. You set up a logical if statement for the conditional. If the logical if statement evaluates to true, then the experimental flow follows the path connected to the little check mark at the bottom right corner of the node. If the logical if statement instead evaluates to false, then the experimental flow follows the path connected to the little X mark at the bottom left corner of the node. The logical if statement is set up via the attribute, comparator, and value properties of the node. The attribute property is like the left side of the conditional statement. The comparator is the type of comparison we are making for the attribute and value properties, and the value property is the value to which we are comparing the attribute property. To put things a little more simply in the context of this example, we're comparing the actual key that was pressed that led the keyboard response trigger to fire to the correct response column of the trial data source. The correct response column of the trial data source stores the key corresponding to the correct answer on each trial. Following the check accuracy conditional, we use 2 more update attribute actions to set the values of our 3 variables. The set correct action sets the same 3 variables that the reset variable node sets, but this time it gives them values corresponding to the behavioral data for the trial. Key pressed is set to a reference to the key component of the triggered data that is collected when the trigger fires. Please note, it's very important to make the reference to the key property of the triggered data of the keyboard response node. Anytime you're trying to reference data that is collected from triggers, you should stick to its triggered data. The keys property of the keyboard response trigger, for example, is just a list of the keys that the keyboard response trigger can accept, in this case, / and Z. So, when setting the key pressed variable, we want to stick to the key property of the keyboard response trigger's triggered data. The RT value is being set by the second line, and it's being set in a bit more of a complicated way. You'll notice that there's an equal sign at the beginning of its value box. This means that what follows is going to involve a combination of information. The INT part and the fact that the rest of the calculation is inside of parentheses following the INT statement means that we're converting the result of our calculation to an integer. The unit of time in Experiment Builder is milliseconds, and our response devices are not precise down to the sub-millisecond level, so we don't want the RT variable to have any decimal places. Finally, inside the parentheses, we're subtracting the time property of the display image action from the time component of the triggered data that's collected when the keyboard response trigger fires. I'll remake this entire box to illustrate this process, as it's a bit complicated. So, we're effectively setting RT to be the amount of time that elapsed from the onset of the display image action until a key is pressed. The accuracy value is simply being set to 1, as this node is on the true path following the check accuracy conditional, meaning that the participant must have responded correctly. The update attribute action called setIncorrect sets the values of the variables in a similar way to the setCorrect node, with the exception that the accuracy variable is set to 0. Finally, and perhaps most importantly, we want to make sure that the values of these variables are written to the eye tracking data file at the end of the trial. Experiment Builder can automatically write the values of variable nodes and data source columns to the eye tracking data file every time the project exits the recording sequence. But to make it do so, you must go to the topmost level of the structure panel and click on the EyeLink DV variables property. This will bring up an interface that allows you to select the data source columns and variable nodes whose values will be written to the data file at the end of each trial. By default, all of them will be on the left side of the interface, meaning their values will not be written. Simply select them and move them to the right to have Experiment Builder write their values at the end of the trial. The EyeLink DV variables that have been selected become trial variables in Data Viewer and thus can be included as columns for any of the data reports that you create in Data Viewer.